In Houston, I'm John Herder. Tuesday, the first day of December. Great as always to have you along, everybody. In a nutshell, From the Expert Show is a compressed virtual networking accelerator, helping people across industries connect very quickly in a brief, moderated, interactive show format. So, what's in it for you? Well, the FTE promises if all goes well, your curiosity is sparked, new ideas come to light, and you may have helped the other person solve a problem or reach their opportunity faster. Networking has never been more important for your business. Studies show that we're more connected when we can see each other. So, if at all possible, turn on your screens. We'd love to see it. And by the way, write your name on your screen by clicking those three dots on the top right side of your own screen. Today's show features two experts, Venkat Bahl and Pat Hogan. Venkat is the Chief Revenue Officer of Sentient Energy, creator of grid analytics systems that make power delivery safe, reliable, and solar ready. He's got more than 25 years sales and marketing executive experience. Emerson Process Management, Philips, Ember, Apricon. He's a founding member and former chair of the Zigbee Alliance, which was a developer of key industry protocol, enabling the edge of the smart grid and IoT businesses for industrial and commercial segments. Second speaker, Pat Hogan, Executive Vice President, Utility Technology Solutions, a startup bringing emerging technologies into gas and electric utility industries. Pat's a 30-year veteran of gas and electric utilities, most recently a Senior Vice President of Pacific Gas and Electric, responsible for PG&E's electrical system. Prior to that, he held officer roles, BC Hydro, National Grid. Gentlemen, thank you both very much for making time to join From the Experts today. Pat, starting with you, as an operator from the grid for many years in the US and in Canada, well, maybe you can start us off by setting the scene a little bit. Some history. How did we get to, well, where we are today?
Great. Thanks, John. And thank you for having me, and welcome everyone. What Venkat and I are trying to accomplish today is really just raising a level of awareness as to what's happening on the electric grid out there that all of you use every day. But if you're like most people, you only think about electricity when it goes out, or maybe when you pay your bill. But that's the extent for most people. It's kind of something that most of us take for granted. The electric grid began way at the beginning of the last century. Electrification has been deemed the greatest achievement of the 20th century by the National Academy of Sciences. So pretty cool stuff. It's also the largest machine ever built. You kind of think about North America, there's really three big grids. One, the eastern grid that extends from the coast all the way to the Rockies. Then you go over the Rockies, and you got the western grid that goes all the way to the coast. Then Texas has its own grid, and each one of those is really the largest machines ever built. They operate synchronously together. Even though there was huge growth of the grid as the century progressed, really the grid that we know it as today really was built out after World War II. Incredible growth in North America, and the grid grew along with it. And as a lot of infrastructure in the United States and Canada, that infrastructure is nearing the end of its useful life. And this is coming, so that really requires a significant investment just to kind of keep up with the type of service that we've been able to deliver to this point. But that's coming at a time when things are changing pretty rapidly. Climate's changing. The approach to how we deliver electricity is changing, particularly on the distribution system. And so, much like how the industry changed back in the 80s and 90s when independent power production came into play, there's really a significant change underway on the distribution system. Really, what's creating two-way power flow on the distribution system. It is a grid that was really built out with one-way power flow in mind. We built these large centralized generating plants, big transmission lines to bring it to load centers, and then distributed the generation to homes and businesses. And that really was done with really one-way power flow in mind. And if you think about today, all your neighbors that have solar panels and maybe batteries and electric vehicles and the windmills that you see and whatnot, that's really creating two-way power flow on the distribution system. And so we need to engineer to be able to deal with that two-way power flow, this transition from one-way power flow and distribution system to two-way power flow on the distribution system. And obviously that requires a tremendous amount of investment as well. So if you kind of think about that, as I mentioned, the growth of the system really occurred back after the end of World War II. And as we were making huge investments in the system, we were also expanding the customer base to be able to pay for that. And now we have huge investments, both replacing the existing infrastructure, but we can't do it on a like-for-like basis given the changes that are occurring. And so that required investment to modernize the grid is coming at a time when the load is flat. So there's going to be huge challenges for the entire industry and our customer base to be able to deal with that. I'll turn it over to you next, Venkat.
Yeah, so thanks, Pat. So as Pat talked about, right, we go from power generation, transmission, distribution. And so really today, we're going to be focused a little bit more on the distribution side of the grid. And as Pat said, it's really hard to just say, hey, we're just going to, even if we were to do the like-for-like replacement, Pat said, which, it's kind of expensive. I mean, $2 trillion, it's a lot of spare change for us to find, in our couch cushions these days. So that's, that's going to be tough to do. And, there's also just to kind of bring home the point, right, that the growth curve that we had after World War II, as Pat was saying, is it's certainly flattened out. And the other interesting thing is, as you got these, the aging infrastructure and, and also the, as we call them in our industry, Pat, I think we call it, and certainly in our industry, I don't know if the rest of you also call it the silver tsunami, right, of the aging workforce. And it's an issue of, how do you continue to operate our grid, and Pat's lived this, for several years as well, in a very challenging environment that we have. So it's very expensive to rip and replace, shortage of expertise, growth is, flattening. And now, as Pat was saying, right, with the advent of distributed generation, some of the conversations we're having just before the start of this session, it's a whole new world out there, right? So the passive grid's going active. Pat talked about the two-way power flows and the engineering that we're going to have to do. So as you can see over here, we're going from a substation typically, and then out here is your centralized power plant, and eventually this comes out to your homes, right? Well, now you start putting in microgrids, you start putting in, solar panels in your homes, these battery walls that are in inverters that are starting to be deployed all over the place. And as Pat was saying, you've got no power flow in the opposite direction. And what does that do to your grid? Is, your protection schemes, your fuses, all of that has been, looking at how you go from left to right. All of a sudden now you got, things going from the load or the homes or your commercial or industrial facilities back into the grid. And so the engineering, impacts are significant to reliability. And like, as we started off this conversation, that's when we start thinking about the grid. Ooh, power just went out. Well, what happened? Did your neighbor just put way too much energy back into the grid? Electric cars and EVs, there's a huge amount of investment going on. Several countries have talked about, going completely, to all new EVs in the next, 10, 20 years, depending on which countries we're talking about. Now, if you think about electric vehicles, they're batteries on wheels, right? And what is a battery? Nothing but a storage device that stores energy. So it uses that energy to move. Well, sometimes that energy could actually be used to go back into the grid. So you not only have grid to vehicle, but you also have now vehicle to grid potentially happening in the not too distant future. So all of a sudden you've got this unexpected demand and supply coming in and off your grid, which again hasn't been planned for. I mean, was it, Pat, in the start of the last century, as you were saying, right? I'm pretty sure that we weren't thinking we're going to have Teslas all over the place, and certainly not in autonomous mode with people sleeping at the wheel. It is strange times that we live in, right? The other thing that, with the democratization of generation, peer to peer, right? Two places can start, transacting, amongst each other, and without necessarily going through the utility. Now, the utility is asked to go and provide an infrastructure to allow this marketplace to happen of, trading energy. And microgrids, now it's not necessarily that a utility puts in a microgrid. It could be, an entity. So with all these massive changes happening, layering on to what Pat was saying about, how the grid came about, how we grew it for a particular use case, the use cases are being completely disrupted. The usage of the grid is being completely disrupted. And now the economics of utilities as well are being disrupted, right? Because they no longer are necessarily going to be in the long term, the person that you pay your bill to. Maybe you're paying it to your neighbor. We don't know, right? So there's a ton of, emerging opportunity, but also challenges. And so what we're struggling with is, well, what do we do with all of this? And if that wasn't enough, wait, there's more, right? So now we're starting to look at climate change, right? And you could argue, is it happening? Is it not happening? Today's not the forum for that. Let's talk about what these extraneous circumstances mean to us and how we experience them, right? So on the left-hand side of this chart, you can see, wildfires. We just picked that as an example. And since the 1960s, you can see over here, the top 5 years, I think this chart only went up to 2017 or 2018, they all occurred from 2006, 2006, 7, 12, 15, and 17. So that tells us something, right? And if you look at the bottom chart, the bar chart over there, that looks at the number of wildfires in terms of the acres that have been burnt by wildfires by decade. So I don't know if you can see my cursor over here. The last two bars on the right is 2000 to 2009 and 2010 to 2019. So you can see that really sharp uptick in terms of the devastation that wildfires are causing. Now, guess what? Everywhere that there are wildfires, there's electric grid. More often than not, there's electric grid operations going on. There's equipment that we have to now consider, right? Poles, transformers, switches, all kinds of things that get impacted. In 2018, at the bottom of that chart, you can see in California, there's 1.8 million acres that were burned, right? And if we thought California was tough, this isn't a North American problem, folks. Australia had 46 million acres that burned, right, in 2018. This morning on my newsfeed, Australia has reported wildfires have started again before the official start of the wildfire season in Australia.
Wow.
It's tough, right? What's going on there. And on the right side of this chart, we can see, the other extreme on this case of cyclones or hurricanes, right? 2020, the most number of significant storms or named storms and hurricanes on record, right? The previous high was 2005. Now you could argue, well, okay, it's an aberration. Fair enough, right? But if you look at, according to NOAA, the severity of these storms on average in the 70s and 80s, is category 1.6 to 1.7. Through the 2000s, right, 2000 and 2010s, it's gone up to category 3 to category 3.6 on average per year. So I think that's pretty hard to dispute, the severity of the storms that are hitting us. And guess what happens when storms occur? Typically, lots of wind, right? Lots of wind knock down poles, knock down wires, causes devastation. So, here we are again, Pat being on the, on the operator side for a lot of his experience, and us in the industry, we're struggling with these changes that are having this massive impacts on our investment base, right? So So here's what, the question that we had for the audience today is, you know, we have to modernize, right? It's an aging grid. We talked about that. We've got to invest, therefore. And then there's a need for innovation because we talked about, the changing use cases. And so in the distribution grid, which, traditionally, transmission is where a lot of innovation happened because, that you had these big generation and transmission, and then it came out of the distribution side. So now to compound things, the distribution side traditionally hasn't had the level of automation that the transmission sides happen, but yet the distribution side of the grid is kind of becoming like the new transmission side with all this distributed generation. And so you've got an investment gap, you got a technology gap, you got an economics gap, right? And you've got strange times that we're having to deal with, and we're like, yikes, what do we
Where's the
do?
money come from, and how are you going to get it done? Yeah,
Exactly.
you just answered a few of the questions that are on the in the chat line here. One was about, hey, are we headed to more distributed power generation as opposed to mega power stations? I think you just answered that.
If I
Another
could
one was,
just, John, if I could just add to that, I think it's really one of the, quite interesting dynamics that has occurred over the last 10 to 15 years. My time in this business, it's always gotten increasingly difficult to build infrastructure, whether it's generating plants, transmission lines, gas lines, substations. I kind of always joke around that I think the term NIMBY, not in my backyard, was really created in our industry. And then as time went on, it changed to banana, build absolutely nothing anywhere near anybody. And then a couple of years ago, I heard nope, not on planet Earth. And so it really, we should kind of think about everybody needs electricity, but many people did not want the infrastructure that required it to get it to their homes and businesses really in their backyard. And then you juxtapose that to some of the changes that have occurred, and you particularly look at solar rooftop panels, and you look at a place like California. There's hundreds of thousands of people in California that have put. It's happened across North America, but I just picked California because it's where it's the most ubiquitous. There's hundreds of thousands of people who have put solar rooftop on their solar panels on their rooftop, and kind of what's amazing to me as I think about it is, many of those folks are the same folks that probably would have argued about a generating plant close to them, or a substation close to their house, or even a pole in their backyard. And yet those folks have chosen to put their power plant right on their roof, right? And drill holes in their roof to do it. And so it's, for me, it's a very interesting dynamic in terms of, what customers want, what customers are looking for. The element of control over your energy decisions is really something that that we need to continue to think about as an industry as we go forward.
right. And one of the questions we have here is about the impact on the grid with the increased number of EVs. That's just one of those examples. That's, hey, it's okay. I can put the batteries in my house. I've got a smart meter. You guys, do your job. So I think there's a little bit of that where as the public, we don't really fully understand the massive impacts this has.
Yeah, and it's changing, right? I mean, to date, the grid's a pretty robust. As I said, it's the greatest engineering achievement of the 20th century. So it's pretty robust, and it's been able to deal with the changes to date. We've been able to keep up with it from an engineering and an operations standpoint. But there have been challenges. I'll use Hawaii as an example. The growth of of particularly solar and wind in Hawaii really outgrew the ability for the operator there to keep up with it. Now, Hawaii is an island. I talked about these big grids in the east and the west and Texas. Hawaii is a smaller grid. It's isolated. It's an island. And so they actually got to the point where they had to put a moratorium on people connecting rooftop solar to the system. So, these are definitely challenges. The industry has been able to keep up with it to date. If you put solar up, you put battery in your garage or your basement, you put an electric vehicle in place. The infrastructure is pretty much there to be able to deal with it. But as I indicated earlier, it's really creating this dynamic of two-way power flow on the distribution system that it really wasn't engineered for. And so for the most part, what's really required is what I kind of call eyes and ears. This ability to see what's happening out on the distribution system. You know, it's not that long ago that most electric utilities, probably 10, 15 years, about 10 plus years ago, most electric utilities in North America did not know your lights went out, and for the most part, until you called up the utility and told them. And so, you know, we've come a long way since then. But what's really required is this visualization of what's happening out on the grid, to be able to know what the measurements are at each individual node, from the substation to the individual home, and then be able to react to that almost instantaneously, not getting an operator involved, but setting controls so that you reconfigure the grid automatically based on what's happening out there on the distribution system.
So Pat, in terms of emerging technologies, that's the business that you're very focused in on now. What particular areas, do you find most interesting that you guys are looking into?
There's kind of really two main ones. I saw it in one of the questions somebody asked about kind of cyber attacks. The electric grid is obviously one of the biggest targets, particularly for state actors and others. You think about the damage that can be done to a nation if you're able to shut down the electric grid. And so that is an area that all of us are focused on, obviously across every industry. But given the particular nature of the electric system, that is a huge concern. And so in my current role, looking at emerging technologies, that is very, very high on our list is cyber protection. And then the other one is, as I just really mentioned before, it's looking at that technology that we kind of call it. The term is SCADA in our vernacular, which is supervisory control and data acquisition. Really being able to know what's happening on the distribution system, bringing that information back, and then putting the controls in place out there on the distribution system to be able to react to it. Yeah, just as by way of example, kind of real-time example, there are devices in substations called transformers, and they have what's called tap changers that really move in unison with the load that's happening on the distribution system. So the typical load profile for eons, where people got up in the morning, they turned on the coffee machine, they turned on their lights, load started coming in, people showed up in the office, industry started. Then you got to the nighttime and people got home, lights went on, summertime air conditioning went on, and the like. And so there's this kind of predictable load profile that occurred. And so the settings on those pieces of equipment that help control the voltage and keep a steady voltage to your home, there was a lot of set it and forget it with this kind of one-way power flow in mind. And as by way of example, I love this example. One of the vice presidents that worked for me when I was at PG&E, he'd grown up in PG&E, he'd been an engineer. And some of the young engineers would tell him when they were looking to change a tap setting in the transformer in a substation, they were like, "Hey, Kevin, you're the last one that changed this 30 years ago." That doesn't occur today. We need the type of devices all along the distribution system that basically are reading and responding automatically. And so those are some of the interesting technologies that I think are going to have huge growth to be able to enable utilities to meet these changes.
And beyond that, if I may add, Pat and John, so there was a question about EVs and stuff, right? So I was in this kind of interesting conversation with the guy that was running, part of the EV program at GM, and he was talking to, a bunch of us in terms of the, let me just get this poll off over here, in terms of the impact of chargers and EVs. And here's the interesting thing: you got guys like ChargePoint or these Teslas and all these guys, GM, et cetera, that are starting to put in all this charging infrastructure all over the place. Now, it never occurred to them, the people putting in this charging infrastructure, that they need to be telling some of these utilities as well where they're putting this infrastructure in. So even the simple things about coordinating across different industries now, because of this overlap that's happening between, in this case, the EV space or automobiles and the grid and electric utilities, just that coordination needs to get a lot better. So simple things about, beyond even the technology bits that Pat talked about, be it in cyber or be it in two-way power flow and monitoring, is how do we talk to each other in a way that we can plan better. I thought that was a pretty fascinating one, Pat. It was a couple of years ago at AEP.
Yeah. I think,
So folks,
another interesting kind of little factoid is as you think about some of the changes that we've seen in our lifetime, particularly around computers and phones and the like, and the provisioning of electricity really has not changed at that same sort of pace. And so as I kind of look to the future, one of the examples I like to use is, is there the possibility that as things like the price of solar and the price of batteries go down, is it possible that people may want to start to disconnect from the grid, similar to how people chose their cell phones over their landlines? Is it possible that 20 years from now, most people are just generating their own electricity with solar panels or windmills, and then when that goes away, having batteries in their garage or the basement to be able to serve their electricity? And so as a longtime person in this industry, I don't see that as the likely scenario. I recognize that I may be a bit myopic in that, but I think it's possible. I always hold out that possibility because, as I said earlier, there's huge investment that's going to be required in the electric grid, and basically without growing demand, that means higher bills. And so, is there a possibility that customers may want to say, "Hey, I'm gonna disconnect and be able to generate things on my own"? So I don't dismiss that as a possibility, but I don't think it's likely. I think the world is moving towards more interconnection, not less, more information sharing, not less. And I think that's what's going to drive the way to keep electricity affordable for everyone.
interesting. So folks, we put out the poll. We'll walk through that in a minute. If you haven't had a chance to answer those questions, please do so. Venkat, we going back to the environmental issues, the wildfires. One of the questions was, hey, were some of the fires actually caused by grid issues? Are you aware of that? You or Pat, do you have a good insight to that?
I can take that, Venkat.
Yeah.
When you look at wildfires, they're the most damaging ones have been occurring in the West. A lot of people don't know this, and I actually didn't either until recently. But it's actually more wildfires in the East than there are in the West. But they don't last as long, and they get put out, and they don't spread as fast. But the most damaging ones are in the West. By dint of electric lines traveling through forested areas, and by dint of the urban wildfire interface becoming so much closer, people building homes in places where there weren't homes years ago. You do have this, you have overhead electric infrastructure. If it comes in contact with vegetation, can in fact cause wildfires, and in fact has. The vast majority of wildfires are not caused by the electric grid, but some of the more devastating ones in California were in fact were initiated with contact with the electric grid.
Okay, I think I just shared the results, so we can walk through this. Most everybody. Venkat, do you want to walk us through these questions?
Yeah, so I guess we had a few questions that we wanted to get some feedback on, and part of these questions, and I know we're going to get to the section pretty soon, John, and as to what do we want from the audience as well. So we started thinking about the importance to modernize, invest, and drive innovation for the distribution grid in the face of these challenges. And it looks like 90% almost of us have said, yeah, we should. The challenge that we have, and I think one of the questions as well that's attached to this particular question that somebody in the audience has asked is, well, what are we doing about it? And as we invest more, it means in the industry, it means you as a consumer pays more, right? And as soon as it starts hitting your pocketbook, your checkbook, you're like, hey, yeah, I'm not so sure I want to spend more money. And so it's an interesting conundrum, right? And it is a challenge, and this is part of why we're here talking, talking to you, the experts, is to say, hey, what is it that you're seeing in your industries, and have you dealt with similar issues, and if so, we'd love to hear about that. So I'm glad to hear that everybody thinks it's important. The big question is how and who is going to pay for it, right? Is kind of what we're constantly grappling with. Now, a lot of work is being done. I don't think either Pat or I want to give you the impression that, we're all over here just sitting and twiddling our thumbs. I mean, there's billions of dollars going in. Some of it was government funded. A lot of it is, funded by, by the utilities through the customers, like you and I. As we pay our monthly bills, please do keep paying those bills. And as we keep allocating larger and larger parts in the industry towards innovation, the more of course the grid gets modernized. So it's good to hear that I think, Pat, one of our objectives was to raise awareness. So I'd say 89% have said yes, they're aware that we need to continue to invest. So that's good. The second question is, are you aware of new or existing technologies from your industry or other that may be applicable to the smart grid challenge? So, half of you said yep, and the other half have said perhaps not. So really, I think, John, I'd love to be able to open this question up to the team, but let me quickly hit the third question, which is, are you or someone interested in investing in distribution automation and smart grid technologies? Some of us have said yep, 7%. So a little bit of perspective. So Sentient Energy is a part of a pretty large organized company called Koch Industries. And so the question that this came up with is, kind of with that in mind, right, is we are looking at, the electrification of everything happening. And so the question is really from that perspective is, hey, what are these, whether it's directly in the space or adjacencies of, technologies or innovations that could potentially help us solve some of these, problems that Pat and I have hit at a very high level. And so absolutely, the 7% of you who have some stuff, we'd certainly, love to understand more. So John is asking me privately here, I guess I shouldn't say it since it's private, like, hey, give us some examples of these technologies, right? So, well, some of them, as Pat talked about, cybersecurity is definitely something that's of interest to us. The other one is, battery technologies, right? So with more and more storage going out into, the distributed areas, what interesting battery technologies are there? And those battery chemistries are going to be incredibly important as we move forward. So that's another example of, of innovation that certainly we're looking at. And then the third one is, analytics is a really important part. Pat talked about how, we are constantly looking to figure out what's going on, especially, on the distribution grid, right, which is from the transformers, out to the meters, which is that part of the grid that is being disrupted a lot and also has traditionally had less automation. So, certainly a ton of sensors going in there to be the eyes and ears of the grid. But what do you do with that data? And how do you take that and make it into something that's, gives you insights? And then how do you take those insights and make them actionable towards outcomes, right? And so I think the analytics, of course, oft used when everybody's talking about AI and ML, but how do you take those technologies, apply them and solve problems? For example, hey, we've got, vegetation contact on lines, if there's a way for us to solve that, man, we'd be really excited to hear more about that. So that's an example of where, some predictive analytics could help us, say, hey, you are going to have a fault, or you are starting to have vegetation contact that could cause fires, or that could cause faults on the grid and things like that. So those are the approximate envelope of areas that that we're interested in. Pat, I don't know if any major ones that I didn't cover that you'd like to add on.
No, but what I think I do, I'm kind of looking at the questions here in the chat room, so I thought maybe I just hit on a few of them. Why is not more of the grid underground? Really, the short answer there is cost. The cost of undergrounding is about 10 times the cost of overhead. So that's really why the grid was built the way that it has been built. Having said that, the trend is definitely moving towards undergrounding. Really, almost all new developments, particularly on the distribution system, are built with underground distribution. And a big part of that is some of the things that Venkat showed earlier, right? The climate change and the wildfires, the hurricanes on the East Coast. You know, is there going to be a new deal? That's really anybody's guess. But but there's no question there is a lot of investment coming, and I think New Deal like type things are definitely the direction. Whether it gets directed by the federal government or by each of the state governments, and for the most part to date has really been a state-driven thing. That's why you see places like California much further ahead in terms of distributed energy resources than other places. Seems like the grid not being distributed is a higher risk. Wouldn't shrinking it be a positive manner to reduce that? Again, I think that's part of what you're seeing out there is this distributed energy resources, people taking control, putting solar panels up, putting batteries in their garage. The economics are favorable in that. You know, a lot of that is customer choice, but a lot of it is economics, and economics favor that right now for those individuals. But you know, when you kind of dig into it, what's really happening is the people who are not putting it in are ultimately the ones that are paying for it to keep the grid going. And so this is an industry where economies of scale still matter. You know, larger solar farms are much more efficient than individual solar panels on people's homes. Larger banks of batteries are more efficient than you know, smaller ones in individual homes. So you're going to have that balance going forward between the economies of scale versus the distributed nature of what we see occurring.
Cool. So thank you for that. And we have a few more questions, but I think for the essence of time, the FTE promise on time, we're going to go ahead and close the poll and close Q&A. We'll finish responding to the questions on the Slack channel, which I'll give to you if you don't already have. And in terms of, are you aware of new existing technologies and you know, or you want to be an investor, everybody's going to receive each other's contact info. So I would say, please contact Pat and please contact Venkat and continue those discussions offline. So with that, can I say, Pat and Venkat, do you have an ask or a give for the audience today? This is something that we do every show.
I'll leave it to you, Venkat.
Thank you, Pat. Yeah, absolutely. So as I briefly mentioned, you know, we're actively looking to invest in this space, right? So my ask of the team over here is, you know, if you have some, you know, innovation in areas that you think can help the electric grid with some of the problems that we described today. So my ask is to please reach out to me and talk to me, because we're definitely interested in seeing, you know, how do we partner and help commercialize new technologies into the space. It's not easy to do because it's very complex, as we've talked about some of the complexities today. And, you know, fortunately, we've got some of that ability to do so. But look, you know, great ideas, they're very valuable. So we're certainly open. And so my ask, come with your ideas and come with your, you know, if you don't have them yourself, maybe somebody you know that has ideas or companies or technologies or products that would be of interest.
What are you willing to share with the network? What's your gift?
Perfect. So our give is, I will commit that we will put you in front of the right people, certainly here at Coke, right? And certainly I'll tap into my network, and, you know, and Pat's part of that, to if not within Coke, get you in front of the folks that we know that, you know, could potentially help you. So our give is our network to put you in front of the right folks. Again, it's a complex world, lots of different people and lots of different, you know, ways of going about it. If it's not a good fit for us in particular, you know, we certainly can help you navigate, if not through the networking, at least navigate through the processes of how do you engage with utilities. And that in itself is a fairly daunting task if you haven't already done it, or if you're doing it and you're looking to accelerate. I'm here to help. and offer up whatever expertise that I have to either any of you or to people that you know. Would be happy to do that.
Thank you very much, Venkat and Pat. Really appreciate it. So now we're moving into the networking portion of the show we call Leads and Needs. So how can the FTE network actually help you? Well, why not ask each other? Each show we experiment different ways. How do we engage, interact members together? More trust in the group promotes richer, stronger networking, accelerates connections, giving you the opportunity faster. Well, you get it. So today we're going to try a little speed dating. We want to learn more about you in your own voice. So in about 60 seconds or so, share something about yourself. What's your focus in the coming months? How can this cross-industry network actually help you get there faster? And what could you offer to the rest of the group? So the floor is open, and let's get it rolling. Who would like to start us off today?
Hey, John, I can tell you stories.
Oh, here's a storyteller, Mr. Lewis from NASA. Talk to us.
Yeah, my name is John Lewis. I'm the ecosystem manager for Orion. And what we're doing is this is part of the architecture we're building to go back out to the moon and onto Mars, bringing crews back there. We've been basically going from the shuttle approach of just flying a truck to orbit to building back to where we can build things in lunar orbit and go further. Right now, we're got in the pipeline. The first big rocket, you'll see smoke and fire coming out of Stennis in December 20th, where will be the first test firing. They'll be assembling that rocket through the spring, along with the Orion spacecraft, which I'm working on for an unmanned mission launching this summer. And then the manned mission vehicle is actually coming together. I've got hardware coming from all ports to Florida to be assembled, coming to the Cape for a launch in 23 to send 4 crew to the moon and orbit. And we're looking at an infrastructure of putting a lunar base in orbit, and then being able to do more long duration explorations of the moon. Right now, probably our biggest needs are, I've got a lot of hardware coming, and we're having challenges, right? The challenges we have is making hardware that you're absolutely sure is going to work when it's, because there's no short trip home, right? Seven days. If I can't keep the crew alive, they're dead. And so I've got to really be careful about failures, and I've got a fairly stringent testing approach. But looking at other guys, how y'all do your testing approaches to better understand that.
Thank you very much, John. So everybody connect with John Lewis. If you can get him to the moon faster, that's what we need. Okay, who's next?
This is Regan Rodriguez. I'll be brief. I found this very informative. Thank you for putting this together, John. I work in disaster relief. I get plastic from the ocean. We convert it into shelters. So I do build off the grid homes with solar, water at the top. And again, this has been very informative just because I'm able to hear from people that are like-minded.
So Regan, looking forward into next year, I mean, what are a couple of the challenges that you're trying to get at?
Yeah, the biggest challenge I have is I have a FEMA contract, obviously, with things like the hurricanes, the wildfires. My homes they're fireproof. They're also earthquake proof because they're not going to crack. And then they're obviously hurricane proof because I shape them like a dome for the aerodynamics. So my biggest challenge is fulfilling the orders. When you were asking about the question about investing, that third question, does anyone want to invest? I had to chuckle at that, and I put no, because I'd want it going towards me. So no, that's my biggest challenge, is just fulfilling the orders. As you guys know, when it comes to anything in sustainable energy, whether you're looking at wind farms, solar, that's not exactly bankable. And your typical private equity venture capital group looks at that as maybe not as profitable as the other ventures they get into. So I think what we have to do is just educate people that it's a good cause to give.
Well, thank you very much.
Looking at just the numbers.
Thanks, Regan.
Sure,
who's
you're
next?
quite welcome.
Yeah, my name is David Lee Jones, and I'm actually in Canada, and I was a CEO for a distribution company called West Stereo Power. And since then, I've started my own company, which I've always had for a while, called Modern Technology Solutions. And this presentation today was really informative because it's kind of aligns with the areas of interest that I want to be involved with in the coming years. Virtual power plants is an interest that I really do have, especially from the residential energy storage perspective. And I know Venkat did talk a little bit about battery storage and the evolution of that. And that's going to be a big thing. And in terms of understanding residential customers who want to go into this area as the backup power, have resiliency, how can you aggregate all of these customers to create a virtual power station to help in terms of demand and response management? And how can that provide value to the distribution system? So that is really an area I'm looking at. I think it's emerging slowly in Canada. As you know, the utility industry is heavily regulated. So I think the regulator will have to play a role in terms of how does the utility and also the market evolve around these technologies to enable them to become more effective and more reliable. So that's really an area that I definitely want to look at in the coming years. But I think, Venkat, I think your role in terms of controls play a very critical part in terms of these power plants and how they integrate with the distribution grid and understanding the controls between the two. So really, that's where I am today.
Thank you. You guys connect later. Who's next? Oh, and by the way, folks, we've passed the 45-minute mark, but I'm rolling with it. So let's keep going.
Hey, John, I'll jump on. Hi there, I'm John Holvik. I'm with Siemens Energy. Siemens Energy is a newly spun off company from Siemens Oil and Gas. It started October 1st. Siemens Energy is still owned by Siemens. It's about 91,000 people in the group. We are dealing mainly in the marine and offshore area in my division in Houston. But we're also strongly looking into wind development offshore, and we're going to be a player there. Our sister division is Siemens Gamesa that make the wind turbines that goes on the power the windmills. And also very interesting, I think, for offshore is that the electrification of offshore vessels is coming more and more, starting with hybrid, but maybe, of course, in the future it's going to be all electric. And they're already looking at Powerboy charging stations to be put out and distributed in the Gulf, where they can actually go up with a vessel and charge their batteries offshore. So there's interesting stuff coming there, and in Siemens we're following that very closely. So mainly I'm on offshore on this stuff. It was very interesting, John, your onshore stuff today, but it's all technology, right? So I'm looking forward to work.
You're right. We all got to get connected through the grid in some form or fashion. So who's next?
Hey, John.
Got it, Chris. You got 30 seconds.
I'm still playing in oil and gas and condition monitoring. Love the discussion about wind farms. I'm actually doing through water wireless communication for integrity monitoring of offshore structures, oil and gas and wind. And as you know, moving into the service sector in my retirement, combining sailing and wine. So if anyone likes to drink wine or go sailing or wants to learn how to sail, get in touch.
Got it. Marcus, I see you're on the line. Talk to me.
Yeah, hi everyone. Mark Seaman, co-founder CEO of CowWave Power Technologies. We're a wave energy developer, so I'm quite interested in anyone that is in need of off-grid power offshore. We're funded by DOE to conduct the open ocean pilot that's going in the water next year, and we're actively looking for pilot end users to deploy a next project with us, potentially in the Gulf or elsewhere, so we can provide 5 to 10 kilowatts and 50 kilowatt hour storage and communications anywhere offshore. So if that's of interest, please reach out. And then we have a larger system that's a 150 kilowatt system that's in earlier R&D stage.
Thank you, Marcus. Be sure and follow up on the Slack channel to post your needs, people. And that's exactly what it's for. There's the leads and needs channel on our Slack station. Who's next?
I could go. This is Chris.
Hey, Chris. Good to see you, man.
Hey, good to see you. Hey, I'm Chris Seckel. I'm with a newly formed group, Hitachi Power Grids. We're ABB spinoff, so similar to the Siemens gentleman. I'm involved in the software to enable smart grids to do the optimization of the DERMS, the SCADA, the various software components to make all of this possible to help all this switching. So I'm very interested in this conversation. I'd like to connect with a few of you. Definitely interested on the investment side as well. So please reach out and I'll do the same.
Thanks much, Chris.
Thank you.
Who's next? Who'd like to go next? Amanda, you still on the line? Tell us just a bit about what you're up to.
Okay. Hello, we are Amanda and Amanda, and we work for our own company. It's a women-operated and owned business called the Energy Think Tank. We've been in business for 12 years. We are a continued education course training company, as well as an energy think tank. So we have created startups focused on oil and gas, enhanced oil recovery, and gas lift. We do work with a lot of data analytics companies, so we are business development as well. And now we're looking at renewables and non-renewables. And we believe that the oil and gas industry will be able to lead the way for making these changes that are critical, not only for the US, but for rural companies, third world countries. However, like you said, education is key, engineering is key. So I feel that, you know, we're very much so aligned with the discussions that we're having today.
Good.
And we're in Houston, Texas. And again, this is Amanda Labrie and Amanda Scott. Yes. So.
Thank you, Amanda Squared. And by the way, you asked a question. Yes, everybody who joined the show gets each other's contact information. That's how we accelerate. We help each other get connected and take care of business after we're done. So now word from our FTE underwriters. With so much changing today, staying connected, sharing fresh ideas, building new relationships, and networking with existing clients without having to sell is challenging. What if you could add a smart strategic tool that complements and enhances what you already have going on to grow your business? So from the experts, today is seeking 5 to 7 companies, underwriters to our 2021 program, help advise, influence programming and content. So from an 8-member startup in April, we're now 381 members and planning a 10 times growth by this time next year. FTE might be the right fit for your business. Let's talk. Stay connected with your FTE network, folks. It's never been easier. It's so interesting. I can't figure out, is that my noise? So we've got a website at fte.network, and join us on the Slack channel that I just sent to you, and tell a friend. Well, we're out of time, folks, but our next show is on Tuesday, January the 12th, where we'll have guest expert Ryan Anderson. He's VP Global Research Insights for Herman Miller, furniture designer and manufacturing. His team struggles with distance innovation. On the show, he's going to share the pros and cons, what he's experienced, and get input from you, the group, like we always do. So sign up right now on fte.network. How are we doing? In 30 seconds or less, I'm sending the survey. Please share your ideas and feedback to make this show and your network accelerator better for you. Thanks again, Venkat and Paul. Pat. We really appreciate what you did for us today, the conversation, very interesting. And folks, thanks to all of you, and hope that you are going to make this the smartest 45 minutes of your day. That's all for today. Wish you happy holidays and take care. Have a good rest of your day.
Thank you.
Thank you very much. So if anybody wants to stay on and talk for the next 5 minutes, we still have some time within the hour. I'm available. Marcus Abisola, thanks for joining. Roy, I'm glad you joined us. Ian, Kenneth, thanks very much. Look forward to seeing you on the next show. Take care.